Welcome. First of all, we thank you guys for coming. We're all very excited, and by all of us, I mean the three of us on stage, that you're here to listen to this talk. I did want to mention really quick, the format of the talk, we're going to try to fill the time with content, and then the Q&A is going to be right outside. So if you guys have questions or you want to hang out and talk, we're more than happy to do that, but we're probably going to do it outside at the table designated for doing that. Also, I know there's three of us, and you're all going to be trying to see all of us, so we're probably just going to dance around each other, so apologies if there are black zones that you can't see us. But let's go ahead and get started. I know we've got a very finite amount of time, and we've got a lot of stuff to go over, so we have a very simple agenda. We're going to do intros, which would probably explain why we're up here on stage. And then we're actually going to go through, we're going to look at developing for Magic Leap and spatial computing through the lens of the three disciplines that we represent. So design, production, and tech. We're going to break that down from each of our perspectives, and all together, we're probably going to give you a pretty good view of creating the Create experience for Magic Leap. So without further ado, introductions, I will start. My name is Jeremy Vanhoozer. I'm the Senior Creative Director for Magic Leap Studios. Magic Leap Studios is the first-party development group within Magic Leap. We get a shot at building experiences for the device. We work very closely with the hardware and software teams within Magic Leap. Before coming to Magic Leap, I spent the previous 5 years at the PopCap studio as Senior Creative Director for Plants vs. Zombies. Before that, I worked at Disney and Cartoon Network, so I've had the privilege of working for some pretty cool creative companies, including Magic Leap. So I'll let these guys introduce themselves.
Yeah, I'm Dan Lehrich. I'm our Senior Director of Production, so I oversee our internal content development as well as work with some of our close partners making content. Before Magic Leap, I was an audio director, I was a creative director, I worked in production, kind of done a little bit of everything. Been at Activision, Disney, and a couple other smaller studios as well.
Hi, I'm Martin Smith. I'm a lead programmer at Magic Leap Studios working on Create. I've actually been at Magic Leap for a little while, so prior to Create, I got to work on a bunch of different projects in mixed reality, exploring that space. Before Magic Leap, I've worked at a mix of doing things like R&D for computer vision, AR, as well as some independent game development and working at other studios. So.
I'm also noticing how much more rustic Dan looks with his beard.
I've been working on it.
This is a clean shot of you.
Yeah.
So first of all, let's start off with a simple question. So what is Create? How many of you guys in the room have interacted with the Create experience on the Magic Leap 1 device? Anybody? Two, okay, decent number. How many people have no idea what Create is and are just here to, okay, I like all of you, this is good. I think we're gonna try to give you a good rounded view of the Create experience. If you've seen it on the device, you're gonna know a lot more as far as context. If not, we are going to hit almost every discipline of Create. I think you're gonna be able to associate with this process because anyone who builds anything, you're gonna be able to relate to this. We just have a pretty unique experience working on a developing platform. So I think you'll be able to follow along. I'm going to cheat by showing you guys the launch video that we put together for the creators launch for Magic Leap 1, kind of letting you guys know what Create is all about. So that is Create in a nutshell. Create is a physics-based sandbox that allows users of an ML1 device to bring all kinds of digital content into their space and interact with it in cool, crazy ways. I think it was very important for us to put out a project like this that was inviting and warm and really got people into the idea of spatial computing. So I'll talk a little bit more about that in a second, but I wanted to give you guys some context because we're gonna hit this from different angles. I wanted to set the tone and let you guys know where this started. So anyone who's worked on anything understands that usually things start very small and prototype phase. We had a game jam type event at Magic Leap called Pitch Fest in 2015. And the studios, we did all kinds of prototypes and turned in all kinds of ideas. And one of those ideas was an art program. Now, this is not a great video, but it's the earliest video I could find, and it's from the archive. So that's Andy landing there on a WD3 prototype for the Magic Leap device. And it was an art program that allowed you to paint and draw in 3D space. So you would be in your room, you would still have full visibility of the room, even though you can't see that on the screen, and you could paint and draw in 3D space. Not a completely novel idea, but a really good example of the tech working, a really engaging prototype that got people excited about what we could do. And so it was a good start for us. It was a good thing that we figured art was a really good way to introduce people to the concept of what we were trying to do. So what happened, as I let this video kind of loop, as the studios kind of got into the mode of building an experience for the creator launch, more ideas started to fall into the bucket of this idea. Well, it'll be an art program with spaceships. It'll be an art program, let's throw some AI in there. Art program farming sim. Maybe not, but there was a lot of ideas. And so anyone who's ever designed anything understands that just because you have a lot of good ideas doesn't mean that if you throw them into a bucket, that means it's a great idea. So one of the biggest challenges that I had on the design side was actually starting to make an experience that made sense and was important from those pieces. But I'm going to start, before I get into that, with why create? So I get this question a lot. Like, we work at Magic Leap. All eyeballs are on us. When we do a creator launch, the software that we ship on this device, people are really going to look at it. So why would we ship something like this physics-based playground full of whimsy? And to me, I answer that by saying that there are two very specific jobs that this early experience carries for us. And they're both equally important. One is introducing people to the concept of spatial computing. This is one of our first drawings of how will people put all this stuff in their room. For you and I, for people who tinker with this, for people who are in the industry, this idea, we get it. We want to push it as far as we can. We're already there. For a huge portion of the population, users that put the Magic Leap device on their head, this is new concept. This is a little bit daunting. So the idea of spatial computing is still brand new, and it takes a little bit to understand what we're trying to push with our experiences. So it needs to carry over that educational piece where we let people know what we're trying to accomplish. But for me, from the design side, equally as important, and I think for us, maybe even a little bit more so, is we allow people to have a lot of fun while doing it. Something that I learned early on in design is that if you can combine education with smiles, that's a powerful combination. If people are engaged enough and enjoying something enough that they're going to go through the experience without extra prodding from you, that's really, really good. It's hard to achieve, but I think one of the things we really wanted to do with Create was in tone, in art style, in music, in audio, we really wanted to make sure that people were having a good time. I really enjoy the times when people come to Magic Leap headquarters to check out the technology. They're very sober. They don't want to give you any tell. They're just there to check out the tech. And then 3 or 4 minutes in playing Create, they're on the ground, like talking to the T-Rex, and then relaying stories back to me that I'm pretty sure I didn't put in there. The T-Rex did this, or the T-Rex got mad, and I don't think he actually did. But I think there's a lot of personal stories that come from just general AI behaviors, which I'll talk about in a second. But that combination of smiles and education for us was a big deal. Also, one of the things that Roni, our CEO, tasked us with early was he wanted the Create team to really give people permission to play. And I think that really stuck with us as a team. I think it also permeates a lot of the experiences that Magic Leap has put out early, but people really kind of feeling disarmed and safe in a space to play and explore will do a lot to get people through an early experience. So let's go back and touch on that early point where, from a design perspective, how do you go from that everything prototype to something that's meaningful and actually matters to people that are engaging? One of the things that we realized early is that just because we had a lot of pieces or we were trying to give people a lot of things to do did not mean that it was engaging and something that people would want to go through. So while this is not our entire design philosophy, this definitely kind of sums up what we discovered with Create. There are a lot of cool, fun things in Create. For instance, if you've engaged Create, or even as you saw in the video, we have a whole section of blocks you can build with in 3D space. We also have some blocks that happen to be food. For some reason, people really enjoy building with food. Building with cheese is super fun, just gonna say it. But if you can build with cheese, snap on a hamburger, throw on a piece of cake, put a rocket engine on it, and launch it out of your living room, that really takes it to that next level of, okay, that was kind of ridiculously fun. And so, while this is a really simple example, the whole goal of the design for Create is yes and. If people ask, can I do that? I really hope the answer is yes. And then let's try something else. So if you do engage Create, it's something where we want you to explore those things. There's also a concept that I carried over from working on Plants vs. Zombies, the whole surprise and delight notion. Keep surprising people and making them happy, and they will keep moving through the experience. That is a huge thing for Create. Also, another ism for me, I've heard before, just because chocolate and peanut butter go well together does not mean that peanut butter and pizza go that well together. I've also then been told that maybe some people like peanut butter and pizza, and that's not very fair. But for me personally, I did not want very many peanut butter and pizza moments in Create. So if you're going to give users ingredients to make their own recipe, one of the things that became very, very apparent, and goes back to that first part of the discussion, is that you want to curate what those ingredients are. So after months and months of probably one of the hardest design challenges I've ever had, we went through the hundreds of ideas and prototypes that had been added to the experience, and we curated it down to 5 categories of content: art, blocks, gadgets, characters, and worlds. So I'm going to touch on these really quickly and make sure to set these guys up as they go through the production and tech. But each one of these carries a special place in the context chart, and they all go well together. So art, as you saw in that very first concept, art is a great way to let people express themselves in a 3D space. You can write the word hello. If you're like me, you can draw weird robot drawings all over your room. It's a very personal thing. People will spend hours in Create doing art, but it's very personal. We don't dictate what you do with art, and it really frees you up just to have a good time. It's also something where we wanted to make sure that we didn't go and make a pro tool for art. We just made very robust art brushes. We made them super easy to use, and anyone can get in and make a mess and sketch and doodle. I know, this is another weird robot drawing. Apologies. But one thing I'm holding on here to show you is also stickers. Stickers are a really cool thing that if you don't want to take the initiative to draw, you can obviously put a flaming face on your wall and have a great time. Or if you want, DJ Pizza Cat up on your wall, the star of the trailer, or even a puking unicorn, that's okay. We really wanted to give people the opportunity to do some cool art. Also, what you see at the beginning there was a really interesting UX exercise, which I could take an entire time to tell you about, which is the color picker, where how do you give someone a robust tool such as the color picker, but make it really, really simple. So the other thing, so blocks. This is a simple ad, but it's a really cool extension of art. We allow people to build in 3D space. The team worked really, really hard, and I think Martin's actually going to get a chance to touch on this, a really robust snapping system. So highlights that show the snap, a really good tactile feel to the snap. That's part of the magic trick. But really wanted to keep making it simple and allow people to express themselves in the 3D space. And then gadgets. If there was a hot sauce to pour on the blocks, it would be gadgets, things such as wheels, rocket engines. You're going to see the button block here, which triggers everything in a compound object. I sped this up because there's just so much to do, but putting giant vortexes in your room that actually can clean up all of the digital pieces, building rockets out of digital styrofoam and wood, attaching way too many rocket engines. This really allows people to explore oh, can I do this? Will it snap? Yes, it will. And then if you're like me, say you wanted to build a giant, I think it's coming up here, maybe a vehicle made out of cheese, filling your room full of cheese, you can do that too. And then maybe just drag in a vortex and destroy the whole thing. But I think the idea was these ingredients work well together, and it really allows people to spend time in this experience doing what they want. If there was a secret sauce to Create, I think it is the way that we've put in the characters. We're building simple archetypal personalities that inject themselves and their own AI behaviors into the scene, whether you want them to or not. If you drag the knights in, they don't like each other, they're going to fight. They're going to find ways to fight around whatever you put into the scene. The jellyfish will just chill out. The astronaut explores. As you saw before, he'll scan. He also loves to ride the baby sea turtle. He's also very gentle with the baby sea turtle. He wants to make sure that it's okay. But I think there's all kinds of things that you explore around their personalities. And if you're, depending on what you're doing and who you inject into the scene, everyone has a different experience. So that's another thing with Create. Everyone walks away with a different story. So that was very important to us. And then finally, worlds. We realize a huge part of mixed reality is turning your space into a more fantastical version of that space. So we created a world brush, which makes it really, really easy to change the layout of your space. Right now, we've got the forest brush and the coral reef brush, but you can literally just run the raycast over your room and then put in pieces of a completely different environment. It acts as a great backdrop for the characters. You can mix that with a whole bunch of building components, and you have some really cool stuff. So for us, these were the ingredients that mattered, and it was part of that design process that made sure that all of these things fit together. So that is my part from a design perspective, setting up these guys for production and tech. Thank you very much.
Awesome. Thanks, Jeremy. So who doesn't love talking about production, right? This is like the eat your vegetables part of this talk, I guess. The production team at Magic Leap, the way that we look at this, right, our role is to support, enable the teams to do the best work that they possibly can. And it's something that we talk about a lot as a team. You'll notice I didn't say own a schedule or drive to a date or own a budget, although that's part of it, really. Like when you're building in a new medium like we are, you really have to take a little bit of a different, more holistic approach to how we do this. So really briefly, I just want to touch on a couple of things that we thought about maybe that would help you as you're thinking about how to build for our platform or similar new emerging platforms. So this is a question that I think really haunted me and our team throughout. Like, how do we do this? Like, everything's changing. Like, the platform is developing. You saw that early prototype, which is this like helmet that is like tethered to a powerful computer all the way down to our device that we have today. We're learning things as we go. Things are constantly changing. I mean, how do we ship anything? And we know that Create has to be one of the premier launch titles that we come out with, and it has to make people understand what this device is, what it's for. Hopefully, it has to be fun as well. So, Jeremy has described it as like landing a plane inside of a plane that's landing inside of another plane that's landing inside of an aircraft carrier, something like that. It felt like that a lot, and this was something that we had to be really, really like sort of nimble in order to figure out. So, this is really cliche. Right? Focus, find the fun, but it's extra important when you're working in a new platform and a new medium. Everything is going to take twice as long as you think it's going to. And when I work with some of our partners, I emphasize that to them as well. Like, look, I know you think that's going to take this amount of time, but if I were you, I would double that. Now, anybody who's done production before knows you always take what your team tells you, multiply it by 3 anyway. But multiply it by 6, multiply it by 10. Just realize that things are going to take longer. You don't necessarily know what's going to make sense until you do it. So it's really, really important, and Jeremy kind of touched on this, how do you take everything and bring it into one thing? And that's something that we talked about a lot. That's just a really simple example. Like, at the very beginning of Create, as we were really focusing in on what it was going to be for launch, there's a lot of pull on our team to deliver a local multiplayer experience at launch. And I completely understood why. I mean, I've had an experience on the device where I'm looking at something and I'm like, do you see this? And it sucks that no one can see what you see. We all want to see this together, but the truth is, something like that, right? That feature will expand everything you do exponentially, and we had to fight really hard to kind of convince everyone that we needed to nail this single player experience first, but it was absolutely the right decision, and everything else that we did was better because of it. That being said, like, you can plan for this stuff. There's a tendency to kind of say, oh, well, no one's ever done anything like this before, so we have no idea what it's going to be, right? And depending on the kind of situation you're in, depending on the team you're working with, like, that might work for you. You might be able to kind of just like iterate until you find something and just kind of go as long as you want to, release when you're ready. Like, we had pressure on us to deliver and deliver at a quality bar. And so, what I like to say to the teams is, look, like, I don't want you to tell me how this is different. I want you to tell me how this is the same. I mean, we're using tools like Unity, right, that like, a lot of this is the same as developing for any other platform. You've got concept art, you've got character modeling, you've got rigging, you've got animation, you've got sound design. I mean, these things are not brand new concepts. So when you're sitting there, you're trying to figure out how are we going to do this, how are we going to get this together, thinking about sort of how you can draw from your past experience. Everybody who's come into our platform is coming from somewhere else where they've done something related or tangentially related. Really anchoring yourself in the things that can really help you get sort of like a solid footing, and then that'll give you something stable to go from, and then that's where you can really kind of start to explore from there. Collaboration, so collaboration is key in any game development environment, but at our company, this was extremely important. So the reality is that like Create changed the platform, and the platform changed Create. We were developing them both at the same time. This is not a joke. In the last like 8 months before we released, we were getting a new revision of the hardware every 6 weeks. New hardware. I mean, I've never seen anything like it before. We were doing pre-launch versions of our SDK. Things are changing, things are breaking. We're working with a Unity integration that's in development. It was really, really critical for us to stay really, really close to our partners on the hardware and software teams. And something that we really kind of focused on was making sure that we were building a platform that all of you could use to develop for as well. So, something that I'd like to say a lot is, if we can't do this, that means nobody else can. And that's a huge problem, right? So as we went, we really kind of worked really closely with all these teams. And I can really say that, there's certain features, and Martin's probably going to touch on this more, like the way that our meshing systems work, the way that our 6DoF controller presents itself within the API, some of these other things like that. Create changed those things, and I think that collaboration was for the better, not just for Create, but for the platform as a whole. And then just the last thing, I'm kind of blowing through this because I really want to make sure Martin has time to kind of talk about how we actually built some of this stuff. But a big role for me and a really important job that we have as a studio within Magic Leap is sort of like, why are we doing this? Which shouldn't be confused with why are we doing this? They're two different things, right? Let me explain really quickly. So Magic Leap is a company that is making hardware. We make a mixed reality device. I'm sure you guys know that. That's the bulk of our company does that. We have an incredibly talented group of electrical and mechanical engineers, low-level software engineers all the way through the stack. It wasn't immediately obvious to everybody in our company why we would kind of go on the side and make this sort of quirky thing with like colorful characters and like cheese blocks. And I mean, so it was really important for us to kind of explain to people, why content matters. Roni, our CEO, really kind of subscribes to that Disney philosophy, and I worked at Disney, and I'm sure, some of the other people on our team did as well. The technology exists to give you an experience, and if you're having a sufficiently great experience, then the technology disappears. And I think that what we've seen as people have been trying to create in some of our other launch experiences is that they're not talking about like, how does this controller work technically, or what's going on with all these sensors here. They're on the ground rolling around with a T-Rex as it chases a ball around the room. And that's exactly what we wanted to deliver. And then of course, we could have made anything, right? We could have made a tower defense game. We could have made a shooter. We could have made a farm simulator, right? Why were we making Create? And as this product developed, what I really started to see and what we really started to talk about was, we kind of refer to Create as internally as the gateway drug to mixed reality. So within the first few minutes of using Create, you're actually getting a sense of everything that our platform can do technology-wise in a completely intuitive and fun way. So, you drop a character, it lands on your table, it falls off the table, it runs around. Okay, the device knows about my room. It's got a spatial map of my environment. The characters are aware of that. I've got this controller, I'm drawing in the air. Like, all of these things are kind of coming together, and before you know it, people are kind of understanding like, oh, that's what that platform is for, that's what this is all about, and hopefully what this is, as much as anything else, is a thought starter for all of you. I mean, we really endeavored to build something that could kind of give a sense of everything that it could be on a platform, and that something could be kind of fun and whimsical, and that's really what we kind of set out to do. So without further ado, let's get into like some more interesting stuff. Thank you guys very much, and I'm going to turn it over to Martin to talk about some of the tech stuff.
All right, thanks, Dan. That was interesting stuff, I think so.
Oh, well, you don't have to say that. The project's done. We're good.
All right, so I'm just going to jump right into some of the technical challenges that we faced on Project Create. The first one, as these guys both touched on a little bit, was that we started in a little bit of a different ecosystem than the hardware and software platform that we actually shipped with the other month. And this is the WD3 that you've seen a couple of times now. And this was the prototype that as a Create team we actually began working with. And what this was a set of different systems. It was an optical system, it had some sensors, and most importantly, it had a big old set of cords that went into a beefy Linux machine. So our original build target was Linux. And we had a lot of ideas about the sort of things that we needed and the sort of things that we wanted to do in terms of things like 6DoF, meshing, but we didn't know what it was actually going to look like. We didn't have exact CPU specs, GPU. We didn't know it was actually going to be available for the hardware. But we did know, essentially, that we were building a mobile device, we were going to target high-end mobile, and that we started from the very beginning with Unity, which enabled us to semi-seamlessly transfer over time as the platform came online, as OS systems were delivered and SDK matured. So the second issue was that this is a little bit of a new problem for us, right? Because we are not building an environment, we are not building levels, we are going into the unknown. We are going into your space. And it turns out that the real world is a pretty messy place. And there's several reasons for that I'm going to jump into. But the way that we represent the world in Unity is this spatial mapping component. So what this does is it pulls the system level meshing APIs, and at some rate, it'll pull in a set of game objects that represent the meshes that it's picking up in your environment. So if you were to actually pull this into Unity, it looks something like this. So there's a couple of things that you'll notice about this. First of all, it's block meshes, right? So all of these separate components that you're seeing are chunks of the data. And these are meter cubed regions that represent a couple different points in space. And there's a couple of key things that makes this interesting. One is that it's a pretty scalable solution, right? So if you're walking from one side of your space to the other, you're updating your mesh in real time, you're able to actually update only the parts that are really changing. So that's performant and it's scalable. The other things that you'll notice is that each of these meshes by default in Unity is represented by a separate game object. And you have the ability through the Unity API to actually specify a prefab for that game object so you can customize that and make it work how you need. And finally, you'll see a couple of issues maybe, right? You can see that the data is pretty noisy. You can see that there are holes in the mesh. You might see that at the block boundaries, they don't always align right properly. So these are all things that we have to deal with just in terms of the way that the sensors pick up the data, on top of all the actual underlying issues of actually jumping into an unknown environment. So it's these things sort of compounding on each other that we have to be robust to. So that wasn't just an example. That was actually one of our test scenes that we used throughout development. And one of the things that we did in the early days was block out levels, right? So we would block out things that looked like a couch or things that looked like 4 walls and a ceiling. And it wasn't until later that we actually got meshing APIs more matured that we realized we needed to start bringing in real data and actually pulling that into Unity gave us a huge advantage because even though hardware was changing and it wasn't always easy for us to come by as a team early on, before it was sort of proliferated throughout the company, that gave us the ability to iterate within Unity itself, which was hugely important, especially in the early days, but also consistently over time, because we could actually use that data in a really consistent way, right? It would be the same, you would know what to expect, and we could make sure that it had the set of features that we wanted to test against, like the block misalignment, like the complex curved geo that you're seeing in here, like the holes. And so this is an example of that, where we test some of our algorithms. This is the world brush that you saw earlier, being tested against a lot of those issues that you see. The next issue with world reconstruction is that there are 2 components to it, right? One is the sensor itself, but the other is that this is all being constructed by the user. So if you take a Magic Leap 1 and you put it on somebody's head and you say go, they're probably going to do what they're used to, which is continue looking straight and stand still, which is exactly the opposite of what we need them to do. So as a first part of the Create experience, we take them through this onboarding process where we actually draw them around the room with these waypoints. And this has a couple of things that we accomplish here. One is to actually just mesh the room, and the other part is to teach the user that their actions have a certain reaction in terms of the way that the system is sensing their environment, right? So we're very direct about this. We know that Create is going to be quite possibly the first experience that somebody actually has on Magic Leap or maybe mixed reality in general. And so this is not something that's necessarily obvious to everybody, that you actually need to walk around and look closely at things. But it's something that we teach here. So a little bit about the way we do this. So when user starts, we construct a bounding box around all the sensed mesh data, and we fit that to all the mesh data. As the data increases and grows, we refit that bounding box. So we take a fixed number of points around the user's head, and we project that onto either the box or onto the nearest geo from that direction. So we can see if we project onto a piece of mesh data, we know that there's data there, and they've meshed it properly. If it's not there, then we ask them, you know what, we can't sense the data. Maybe it's too far away. Maybe it's a dark surface. But in either case, the solution for the user is to actually walk up and look harder at it. Finally, at the end of the stage, we enter into what we call open-ended fixing. And this, we give the users the opportunity to walk freely and fill in the mesh data at their leisure. And it's important here that we actually call out and expose issues with the mesh as much as we can. So we take that same bounding box, we turn on a set of red X's, and they say, okay, we need to go look over there. There's a big hole in my data, and maybe hopefully this is also a little bit fun, right? You go around and get rid of all this stuff. And at this stage, hopefully they've learned a little bit so that once they actually begin the proper experience, and maybe if they ignored a whole bunch of red X's and they see a cube fall through it later, they can remember, okay, that was because I decided not to go and mesh that area. Finally, just a little bit about the visualizations here. We take a pretty simple approach, which is to draw the whole mesh, and this is brightened up so you can see it. It's pretty subtle on device. And then we also overlay a wireframe, the actual underlying high-resolution wireframe data. And the thing that that accomplishes is to really present the silhouette and the shape very specifically to the user so that they can see the difference between meshing the edges of a table versus part of a table and then maybe something nearby. So at this point, we enter the create experience proper. We present them with the menu, they open it up, and we bake the mesh, right? So we call this process scan and bake. At the beginning, we're actively scanning. When they complete the process, we bake the mesh. And what that means for us is that we turn off active scanning, and we turn on several other features, like the experience. We bake a navigation mesh through that graph. And there's a few trade-offs to this process. One of the main ones is that we get a lot of CPU cycles back, right, from not doing this in real time, that we can apply towards the actual experience. The other is that we know specifically that what the environment looks like, so there's not necessarily going to be unexpected noise coming in and disrupting the experience. And then having this navigation graph gives us a lot of extra goodies here. One is that ground characters can actually traverse your room even if it's complex, right? They can start from one end, navigate all the way around your couch to a target that they're trying to reach on the other side. And the other is that we can help cover up some of the remaining issues that we see with the mesh. So for example, on the left side of the video, you can see the knight sort of walking around the table. There's a big old hole in the mesh underneath that table. And we don't really want the knight to just walk off and expose that kind of issue. So it doesn't walk off into the void. It avoids them because we have that navigation mesh. And this is sort of the other side of the coin of getting good data, good mesh data, is that we want content to be responsive to it and be robust to the different kinds of issues that we might see. So on the other side, we also have ungrounded characters, and they work a little bit differently. So for ungrounded characters, they also use a little bit of the navigation mesh to get target waypoints, but they are more free roaming in their ability to traverse 3D space, right? So they can move from one side to the other in a pretty global way, direct way. And we rely instead more heavily on local avoidance. So here's an example of a fish trying to reach the target of a sushi block to eat, because our fish loves sushi for some reason. So, in the way between it and the fish and the sushi block, it finds a chair, detects the obstacle, and starts moving tangent to it until it's able to swoop back around and sort of get to the target. And here's a few more examples of some of the tests that we put them through inside of Unity. And this is running at a stunning rate of about 1 hertz on these GIFs here. But essentially, we've got the user moving a dynamic sushi block around, so following a dynamic object, flocking together, moving around a complex set of obstacles. So I'm going to jump a little bit into our physics, because Create as its core is a little bit of a physics sandbox. And I think a fun way to start this is with this video that a user submitted on Twitter, where he built a totally functioning swing set out of wooden blocks for his T-Rex. And he did this outside by meshing a tree and then constructing this wooden, just simple wooden block swing set, and then actually attaching it to the meshed tree, which was not exactly something that we had tested against, but was sort of the kind of thing that we were hoping would be possible once we released this thing into the world. So he says, I can't believe this actually worked.
Neither can we.
Yeah, we can't believe it either, but it's awesome.
Well, here's why it worked. First of all, we leaned pretty heavily on the Unity plus physics integrations. So that as its core is our physics engine, and that buys us quite a lot if we have a good meshing components. The other thing that we built is this robust snapping system. And this is a designer-specified snapping system that is pretty flexible, right? So all of these blocks have snap nodes on each side, and any snap node can connect to any other snap node. So we have a very standard block size, But that's really about making things consistent and easy to use for the user, so that you can build big, complex things, and they all kind of fit together.
We're not saying the T-Rex liked it.
Right, no,
Totally worked.
but we enjoyed it.
There's also a few hacks involved. So,
Workarounds, we call them workarounds.
we'll call them, okay, sure, workarounds. So I don't know, if you've ever worked too much in Unity physics or physics, virtual physics in general, you know that things can get out of hand pretty quickly, especially because if you have forces that start adding together in unrealistic ways. So the way that our compound objects work is that as two objects are snapped together, we build a virtual object that they become a part of, right? And so we have one rigid body for that object, and we maintain virtual rigid bodies for each of the sub-objects. And as blocks are snapped together, we absorb them in this way. We update things like mass, center of mass, and maintain all of those individual properties so that we can restore them later if we need to. And this in general works pretty well. We do things like clamping for velocities and some smoothing on user input to make sure some of the forces don't get out of control. But then for some more complex objects like wheels, which are attached not as child objects, but as joints, we find that when forces start adding up, which they can when the user is involved and there's impossible mesh forces working, they can quickly get out of whack, and those forces will start stacking up over time, and you get into some really wacky situations with parts just flying everywhere. So one of the ways that we mitigate that is to sort of stomp those into place when the user grabs them, because this is one of the main sources of the crazy forces that we get. So when a user grabs a compound object, we fix the wheels, disable their joints, and then restore them as soon as we can. All right. So last, I'm going to talk a little bit about save and load. And this is a feature we just shipped the other week in Create 1.1. And this is actually a pretty interesting problem in mixed reality and in spatial computing. Because if you think about regular saving and loading, at its core, pretty familiar concept. But what happens when you're on a device that you're saving all your things in a particular space, right? You're saving everything in your living room. You expect to be able to reboot your device, come back, and everything will show up, right? Well, in the Magic Leap, and this is a little bit of simplification, but we'll work with it. When you reboot your device, you're in an arbitrary coordinate system, right? You're not in the same space as you were the last session, and this can change over time. So the solution at the Magic Leap platform level is what we call PCFs, or persistent coordinate frames. And what this does is basically gives you a common reference point that's found using visual features in your environment. And at the SDK level, this is a bit of an abstraction that lets you get that common reference frame and either bind or restore content to it. So if everything works as expected, we can bind your saved content to that PCF and then restore it if it's found again. But what happens if you've rearranged some of your furniture? What happens if PCF system fails? What happens if your house is burned down and you have to go to a new space? So there's a lot of things that can go wrong, and we want this to actually work in a pretty consistent way in any of these cases. So that, again, Create is a lot about having a really simple, consistent user experience. So our solution for this, for Create 1.1, and we've marked it as an early look feature because we think we have more to solve still, and PCFs themselves are still experimental in the API. But what we do is we pull, once you save data, you can pull it out of the menu, and you can see here you get this box where content sort of expands into the space, in this case, at the correct location. The user also, however, has the chance to grab that gizmo, and then we basically just put the user in the loop and give them the opportunity to translate and rotate the scene into the space that they actually want it to. And so in addition to helping for the case where the room has changed a little bit, this is also really flexible because it works with, in other cases, for example, you've decided to build a rocket ship, you want to save your rocket ship. It's not necessarily tied to a particular space, right? But you can grab it out of the menu, and with the very same UX flow, you can bring it anywhere that you want. And in the case that the PCF fails, we just put that centered around the gizmo itself rather than around the PCF. So with that, I'm going to wrap up. And thank you very much. We're going to have QA right outside.
I think
Q&A.
Yeah, I would say, just as a sum up, Create's a pretty small experience, but it's a polished experience, and I think what we're trying to do is add some context to everything that we put into getting this to work on a brand new platform. Really, really proud of the team. Appreciate the opportunity to get out in front and talk to you guys. Obviously, using Unity has been a powerful tool for us, and I think we're pretty excited about where we're going in the studio. I think if you see the amount of work we put into Create, we've got some really cool things cooking in studios, and we look forward to sharing those with you. But like Martin said, I think we're set. Did you want to?
I just want to mention that we are hiring for gameplay engineering. So if the things Martin was talking about were interesting to you,
as well as lots more future things.
Come find us, because we're looking for some good people to join the team.
Absolutely. So we'll see you guys outside. Thank you.
Thanks.
Thanks.